Good day, grade 11s, grade 12s. Today we want to focus on trigonometric ratios, which are involving A, P, and Q parameters. We need to maybe look at the effect of each of these parameters. We understand that the effect of A on the graphs is vertical stretch, which affects the amplitude on the graph of sine and the graph of cosine. And then on the graph of tan, it is just a vertical stretch because it does not have the amplitude. All right, looking at P is a horizontal shift either to the left when P is positive or to the right when P is negative. And we must also be aware that P is an angle, it's not a number. And then Q is the vertical shift, which comes as a constant. So basically, what we are looking at here is the change in the amplitude, the change in the stretch, the change brought by the horizontal shift, and the change that is brought by the vertical shift. Now, I have some questions here that we may look at. For each of the functions, sketch the function on the given interval, write down the period of the function, write down the amplitude of the function if applicable, write down the range of the function. Now, questions 2, 3, and 4, you should be able to answer these questions without even drawing the graph. So let's look at these 3 questions and then we'll do the drawing after. Let's take the first question, A. We are given that y is equal to cos x minus 25 degrees. Now we need to check and have the correct interpretation of the parameters that we have. Now here, our A is equal to 1, our P is equal to negative 25. Now these are the only 2 parameters that we are having. So that means our A is giving us the amplitude, which is 1. Our P is telling us to shift the graph horizontally to the right, 25 degrees. The graph of what? The graph of y is equal to cos x. That's the one that will shift 25 degrees to the right to get the graph of cos x minus 25. So in answering question number 2, write down the period. The period is not affected by any of this, so we take the period of the basic, which is 360 degrees. The amplitude, we have already said A determines the amplitude, so the amplitude is equal to 1. Then the range of the function. Now there is no vertical shift. Our Q is 0. So if there is no vertical shift, it means that the range will be the same as of the basic graph. So our range, y is greater or equal to negative 1, less or equal to 1. Alright, let's take another question and see if we can have a correct interpretation. Let's take B. B is y is equal to tan x plus 10 degrees. Our A is equal to 1. Our P is equal to 10. So, answering question number 2, period the period is not affected by any of the parameters. So we take the period of the basic graph, which is y is equal to tan x, which is 180 degrees. Number 3, the amplitude. We know that the graph of tan does not have an amplitude because it goes to positive infinity from negative infinity. So the amplitude we don't have. Number 4, the range. Since it's going to positive infinity and negative infinity, we are simply saying y is an element of real numbers. Well, let's check C. C is y is equal to 2 sine x plus 60 degrees. So here, our A is equal to 2, and then our P is equal to 60 degrees. So now that A is not equal to 1, the amplitude has been affected. So in answering the questions, question number 2, the period has not changed because there is no parameter that talks about the change of the period. So the period is still 360 degrees. Number 3, the amplitude is now determined by A. So our amplitude is equal to 2. And then number 4, we need the range. There is no vertical shift in this graph. Our Q is 0, so the vertical shift, the range is still the same as the range of the graph of y is equal to 2 sine x. That means our y is an element from negative 2 to positive 2. Let's take another question. Let's take E. Now E is y is equal to cos x plus 60 degrees plus minus 2. So here our A is equal to 1. Our P is equal to 60 degrees. And then we have Q, which is equal to negative 2. So in answering the questions, period, there is no parameter that affects the period. So we are saying the period of the graph of y is equal to cos x is the period of this graph also. So it's 360 degrees. That is number 2. Number 3, we need the amplitude. The amplitude is determined by our A, our positive A. So the amplitude is equal to 1. And then number 4, we now need to consider Q for the range. Let's remember that the range of the graph of y is equal to cos x plus 60, the range is y is an element in the interval -1 to 1. So now for the graph where we are having negative q, it means we are shifting down 2 units. So it means our maximum, which is at 1, if we shift it down 2 units, we will now get 1 minus 2, that is our new maximum, and then the minimum will be negative 1 minus 2. So this will give us y is an element from negative 1 to negative 3. Alright, so we are saying here, before you even draw the graph, you must be knowing some of this information. And then drawing the graph is just an icing on the cake. Now let's go on now to sketching of these graphs, which may be a problem to some of us. Let's take A. Now we need to understand the transformation from the basic graph. We are saying we have the graph y is equal to cos x. And this graph has been shifted 25 degrees to the right to form the graph y is equal to cos x minus 25 degrees. So it would be better for us to start with the graph of y is equal to cos x before we come to this graph. So let's be practical about this. I will put the basic graph. The basic graph for cos x. We have been given the interval to use. Of course, the interval is from negative, x is an element, from negative 65 degrees to 385 degrees. Alright, so what we need to understand here is that the basic graph, which I have drawn here from negative 180, so that I can accommodate the 65. We know that this is the graph that has been shifted 25 degrees to the right. So we are saying every critical point is going to be moved 25 degrees to the left. So if we start from here, we know that at negative 180, the basic graph is attaining negative 1. So we are going to move this point horizontally 25 degrees. That would mean moving from negative 180, if we move 25 degrees to the right, we'll get to we'll get to 155. So our new point will be there. This strategic point, which is negative 90, it's going to move 25 degrees to the right, and that will be negative 65. So negative 65. So this point will come here, and then we have this turning point that is at 0 degrees. We move it 25 degrees. So that will be at 25 degrees. That will be our new point. 90 plus 25, which will be 115. That's where the graph is going to cut the x-axis. This point, which is 180, -1, we move the point 25 degrees to the right. That is 180 plus 25 degrees, which will give us 205 degrees. That is where our new point will be. And then here, 270 plus 25 degrees, that will be 295. That's where the graph is going to cut. And then this point, which is 360 degrees, 1, we move it 25 degrees, that is 360 plus 25, which is 385 degrees. So that's where the last point will be. So if we are to draw our graph is going to assume all right. So that's why you see the question is giving you from -65 degrees to 385 degrees, so that it has been designed in a way that these critical points are quite visible. So that's how you can draw this graph easily without having problems in deciding, am I right, am I wrong? It becomes easy. All right, even if I am to add that graph, just as a confirmation of what is happening, that is cos x minus 25 we can see that the graph has been moved. The graph has moved. This is 25 degrees. From here to here, that's 25 degrees horizontally. The y coordinate is not changing, but it is only the x coordinate that is moving 25 degrees. So every point has been moved 25 degrees to the right. So it becomes very easy to draw these graphs in that understanding. Let's pick up another question. All right. Let's say we pick B. Let's take B. Y is equal to tan x plus 10 degrees. So we'll start from the basic graph. And the basic graph is the graph of tan. And also we need to consider the interval that the question is given us. That is from negative 100 to 170 degrees. That is our x. All right. So we are understanding that the question is giving us a shift of 10 degrees. A shift of 10 degrees to the left. And we are starting from negative 90. And if we understand this well, we know that at negative 90 degrees, we have an asymptote. All right? So everything is moved 10 degrees to the left. That's why now it's negative 100. So that we are going to accommodate the asymptote there. So what we can do is to consider the basic graph, that is the graph of y is equal to tan x, and then we shift all the points that will be having 10 degrees to the left. So I am assuming, which is not very proper, but we have checked in, we have done this in the previous lessons, drawing of the basic graphs. So basically this is our graph for tan x, and to accommodate the hundreds, I've taken it from negative 180. And we understand that we have asymptotes at negative 90. You already know about this. There is an asymptote there. There is another asymptote at 90 degrees. And there is another asymptote at 270 degrees. Then, now what we are simply going to do is to shift this graph 10 degrees to the left. So every strategic point, including the asymptotes, we are going to shift them. So if we shift the asymptote 10 degrees, let's say 10 degrees, that is minus 90 minus 10, that will be negative 100. So we are going to have our asymptote now at negative 100. All right, we may not consider what is on this side. Then we have this strategic point, which is negative 45 degrees, negative 1. We are going to move this point 10 degrees to the left. That means minus 10 degrees, we will get negative 55. So our new point will be there. And then this point, we move it 10 degrees, so it will be at negative 10. And then this point, which is another strategic point, 45 degrees, 1, we move the point horizontally 10 degrees, that will be 45 minus 10 degrees, which is 35. So the point will be now having the coordinates 35 degrees. 35 degrees, 1. So we are saying we are going to have our graph moving towards this, the blue asymptote. Here we have this strategic point, which is 135 degrees, -1. We move it 10 degrees to the left. That will be 135 minus 10 degrees, which is 125. So the point now will be having the x coordinate as 125. And then the new point will be here. And then 180 minus 10 degrees, that will be 170. So the graph will now be crossing the x-axis at 170. This strategic point, which is 225, 1, it will now be minus 10, that will be here, and the x-coordinate we are saying is 225 minus 10, which is 215 degrees. And then also checking on this interval, we have already reached the 70 degrees. So basically, we are saying our graph will be taking this shape. And then if we need to proceed, we can proceed, but according to this domain that we are given, we must end at 170 degrees. And let's not forget also the asymptote, which is going to move 10 degrees, that is, now it's at 80, so we need to draw the new asymptote there. Alright, so basically that's the easy way of drawing these graphs, by understanding the transformation that is happening from the basic graph. Alright, I will display the questions for you to try. You can pick some of the questions for you to try on your own and see how easy it is to come up with a graph. Maybe you are having a question to say, what if a question is like G? On G, we are having 3 parameters. We are having our A, which is -2. We have P, which is 13. We have Q, which is equal to 1. So we are saying the A is telling us something about the amplitude, which is 2, and also is telling us about a reflection along the x-axis, and then P is telling us about the horizontal shift, that is a shift of 30 degrees to the left. And then Q is telling us about the vertical shift, of 1 unit up. So where would we start when we are going to draw this graph? We can start we know that the graph of cos x is the basic graph, and then we bring in the amplitude. Y is equal to 2 cos x. You can even have the mental picture of these graphs. Then you effect the reflection. And then after the reflection, you can then now move or shift the graph 30 degrees to the left. And thereafter, this graph, you then move or shift it up by 1 unit. So you get finally the graph that you want. And also remember that the correct interpretation of the transformation of graphs, it is very important that you understand these questions in terms of interpretation, because examiners will never let you go when it comes to asking about transformations. Every exam, every test should test you on your understanding of transformational graphs. So all the time, understand the transformation from the basic graph. So let's draw these graphs. And the interval that we are having, it's from negative 120. X is an element from negative 120 to 330. And remember, we are saying we are shifting the graph 30 degrees. So you can see the 330 is from 360, 30 degrees to the left. And negative 120 is from 90, we are shifting 30 degrees to the left. So on our drawing, we can accommodate by starting from 180 to 360. So we are saying we are going to start with the graph of cos x. Y is equal to cos x. Which is the blue. Alright, just to put some enlargement so that you can see well. Okay, that's the graph of cos x. Now we are saying we are now effecting the amplitude change. So we are moving to the graph of 2 cos x. Alright, simple to understand. Then now this graph is going to be reflected because of the negative that is on A, so it's going to be reflected across the x-axis, or with the x-axis as the mirror line. Alright, so we can see the reflection. It's so easy. The way the graph cuts doesn't change. It's only the points, the critical points that are off the x-axis that will change. Now, let's move to the horizontal shift. which is now the easy part. We are shifting this graph 30 degrees to the left. So the negative 90 will now come to negative 120. So the graph is going to cut the x-axis there. This point is going to move, that is at 0 degrees. We are going to move 30 degrees. So it's negative 30. So our point is going to be there. And then this one, 90, we move, is going to be now at 60 degrees. That's where the graph is going to cut. This point is going to be, it's at 180. So we move 30 degrees, that will be 150. So if 150 is here, then that will be our new point. And then the 270, we move 30 degrees, that will be now at 240. So the graph is going to cut the x-axis there. And then 360, we move 30 degrees, that will be 330 degrees. So that's where the graph is going to attain the maximum. So we are basically saying our graph is going to go like this. It will turn here, and then it will cross at 60, and then it will make a turn point there. Then we'll cross at 240, and then this point will be here, not up there. So it will turn there, and then to end there. So that will be our graph. That will have x, f of x is equal to negative 2 cos x plus 30 degrees. Alright? Now, that's the horizontal shift. So just to be accurate, I'm going to remove my graph and then put the one with the proper measurements. That will be negative 2 cos x plus 30, we shall use a rate okay. All right, so that's how our graph will look. So we are basically saying this is where we have negative 100, that's the critical. Here, that's where we are having our negative 30. Then here, it's 16. Then here, that will be 150. And then here, that will be 240. And then for this critical point, that will be 330 degrees. Now the final piece of this puzzle is to move this graph vertically. Remember, the question is saying plus 1. Our Q is 1. So what is now going to happen is just to move each of the strategic points 1 unit up. That is, this point, we will move it 1 unit vertically up. So it will be there. This one, we'll move it vertically 1 unit up. This one, 1 unit up. This one, we move it 1 unit up. This one, 1 unit, 1 unit, and then we'll be done with our graph. So we are saying our graph should be like this. All right, so I will remove some of the graphs so that we can see well. I will remove the basic graph. I will remove the second graph that we did, the third graph that we did. So we remain with these two graphs. So we can see that now every point is being moved 1 unit, 1 unit up, 1 unit up, 1 unit up. So I'm just also going to put the graph that we want so that we get the accurate part of it. All right, there we go. That's the graph. So it becomes very easy to draw the graph given even all the parameters by following the transformation that happened from the basic graph. I hope this lesson helps you to understand. And then in the next lesson, we'll also bring the change in the period, because in what we have been discussing, there was no change in the period. See you then.